Well, you've made it back for yet another Saxon math lesson. We are moving right along to lesson 9, and we were talking about prime numbers, okay? And as you can tell by the objective, we're not only talking about prime numbers, but composite numbers and some prime factorization, so that's just a whole bunch of good mathematical knowledge. So let's go ahead and get started with it. Before we can do that, though, we got the fun fact of the day, which is every second Americans collectively, means altogether, eat 100 pounds of chocolate. So if you combine everybody in the United States and how much chocolate they eat, it's 100 pounds every single second. That sounds awesome. Alright, let's go ahead and get moving into the assignment, or actually the lesson. First thing we need to know is what prime means and what composite means. So I'll give you a chart here. A prime number is only divisible by 1 in itself. Okay, so what that means, it's like let's look at the number 5. Okay, well I can't divide 5 by anything. Okay, I can divide it by 1, because 5 divided by 1 is 5, right? 5 divided by 1 is 5, and I can divide it by itself. 5 divided by 5, that's 1, okay? But what about 5 divided by 2? That doesn't divide evenly. Okay, that gives me a fraction or a decimal. And when we say only divisible, that means it doesn't divide evenly. There's nothing that divides evenly into it. Okay, so 5 would be a prime number. 5 is prime. Okay. Number 3 is prime. 1 and 3 are the only things that go into 3. Okay. 1 times 3 is 3. 3 times 1 is 3. That's it, though. Those are the things I can multiply together to get 3. Okay. So that's what a prime number means. Composite number is divisible by something other than 1 in itself. Okay. So let's look at, for example, 6. Well, I can divide 6 by 1. I can divide 6 by 6, so it's divisible by 1 in itself, but it's also divisible by 2. And it's also divisible by 3. Okay, so 6 is composite, because we can divide it by other things, other than 1 in itself. Didn't mean to make that mark. Okay, so that's what the definition of those means. So let's go ahead and investigate this a little more. To help figure out if bigger numbers are prime or composite, we have some divisibility rules here. Okay, so what this means is a number is divisible by 2. That means that I can divide it by 2 if the number is even. Okay, so for example, 3,420 is divisible by 2 because it's even. Okay, so yes, it's divisible by 2 because it's even. It ends in 0. Okay? Alright, so to tell if a number is divisible by 3, it says the sum of its digits can be divided by 3. Well, sum of its digits means if I take 3 and 4 and 2 and 0 and add them up, 3 plus 4 plus 2 plus 0, and I add those up, well, 3 plus 4 is 7, 7 plus 2 is 9, 9 plus 0 is 9, okay? And I look at this sum, it says if this sum can be divided by 3, then the whole number is divisible by 3. Well, that's yes, because 9 is divisible by 3. So that means 3,420 is divisible by 3. Okay? Now you might be thinking, well, Mr. Ayers, we could just divide it by 3 and figure it out. Well, that is true, but to me, if I wanted to just know, is a number divisible by 3 or not, it's a heck of a lot easier to go, okay, 3 plus 4 is 7, 7 plus 2 is 9, 9 divided by 3, yep, that works. Okay, I don't have to actually divide the whole thing out to tell it's divisible by 3. Alright, so, let's move on to the test for 4. It says the number formed by its last 2 digits can be divided by 4. Well, I'm looking at the last 2 digits in 3,420, and that is 20. And I can divide that by 4 evenly. So then the answer is yes, it's also divisible by 4. Again, without having to actually divide it out, we know it's divisible by 2, 3, and 4. Well, the 5 test is easy. Does the number end in 0 or 5? Yes, the number ends in 0. So yes, because it ends in 0. Test for 6 says it's divisible by 6, means 6 will go into this if it can be divided by both 2 and 3. Well, 2 was a yes, and 3 was a yes. That means 6 is a yes. Okay? the 9 test. The 9 test is nice too because it's just like the 3 test. If I add up all those digits, 3 plus 4 plus 2 plus 0, that equaled 9. And if I get a number right here that's divisible by 9, then this whole thing is divisible by 9. So again, that's another yes. So this number right here is divisible by 2, by 3, by 4, by 5, by 6, and by 9. And we proved all those with these divisibility tests without actually having to divide anything out. And the last one, 10. This is the easiest one. If the number ends in 0, it's divisible by 10. So this answer is yes again, because it ends in 0. Oh, hey, by the way, if 5 goes into it, okay, and it ends in 0, then 10 has to go into it. Okay, if 10 goes into it, it ends in 0, that means 5 has to go into it. Okay, there's no number that you can divide by 10 that you cannot also divide by 5. In fact, there's no number that divides by 10 that you can't divide by 2, because 0, if it ends in 0, it's even. So see, these things tie together very nicely too. These will come in handy, so make sure you have these down, okay, when we're talking about prime and composite numbers. So let's go ahead and move on to some examples. Okay, and these examples will be where those divisibility tests come in handy. Now we'll talk about prime numbers a lot. So like it'll be helpful for you to know how many prime numbers up to like the number 100. Okay, and I'll give you a sheet to help do all that, because if one of those prime numbers goes into a number that looks like this, okay, then that means that this big number would have to be composite. So for example, 11 is a prime number. If 11 went into this, then that means something other than 1 and 1,237,526 goes into this number. So then it would be composite. Okay, the only way this is prime is if the only numbers that go into this are 1 and itself. Okay? But for the most part, these divisibility tests that we just learned will come in handy. Okay, so I'd be thinking about the easiest ones, like 10. Okay, let's look and see if this is divisible by 10. The rule for 10 said that the number has to end in 0 to be divisible by 10. But since it ends in 6, that's not 0. That means 10 will not go into this. Okay, 5 is the same way if it ends in 0 or 5. Well, we know that that's not true either, so 5 doesn't go into that. The next easiest is usually 2. 2 says if the number is even, then 2 goes into it. Well, this ends in 6. That means it is even. So this number, for letter A, is composite. And our reasoning, it says determine whether the prime is composite and state how you know, is because it is even. So it is divisible by 2. So it's divisible by something other than 1 and itself. It's divisible by 2. Alright, well that was easy enough. How about B? B, again, I'm looking for the easy test first. Doesn't end in 0, so 10 won't go into it. Doesn't end in 5, 5 won't go into it. It's not an even number, so 2 won't go into it. So then I like testing, let's see, the 4 test. That said, if the last 2 digits are divisible by 4, well, I can't take 11 divided by 4. Alright, so I'm already down to, 3? And, well, it can't be divisible by 6 either, because 2 didn't go into it, if you look at those last examples. Okay, those last notes. So, I'm down to the test for 3 and 9. Those are the ones where we have to add up all the digits. Okay, so we're going to take 5 plus 2 plus 0, so 5 plus 2 plus 0 plus 6 plus 1 plus 1. Make sure I got all those. 5 plus 2 plus 0 plus 6 plus 1 plus 1. We're going to add all those up. Well, 5 plus 2 is 7. 7 plus 6 is 13. And 13 plus 2 is 15. Well, I know that 15 can be divided by 3. So that means it's composite, because 3 goes into it. It is divisible by 3. And we proved that with our divisibility test. Added up all the digits and got 15. 15 divided by 3 works. Okay, so it's divisible by 3. So that's a composite number. A big composite number at that. 2 big composite numbers on this slide. Alright, let's go ahead and move on to another example. Example 2 is to write the prime factorization of some numbers. Okay? Well, prime factorization is nice, okay, because it lets you break down a number and write it in terms of its prime factors, which means in terms of prime numbers. So you guys have probably seen these before. There's 2 methods, okay, that we're going to use for 36. One of them is a factor tree, So we can break down 36 in many, many, many ways, okay? I usually like to break it down in what's going to work out to be the quickest. So for example, I can choose any two numbers that I can multiply to get 36. I know like 6 times 6 is 36. Well, 6 isn't prime, so I got to break it down. And the only way I can get that is 2 times 3. 2 is a prime number, so I'm going to circle it. It doesn't break down any farther besides 1 times 2. 3 is also a prime number. Okay? Well, 6 again breaks down into 2 times 3. So if I'm going to write the prime factorization of this, okay, there are two different ways to write it. We can do what's called expanded form, which looks like this, where we write them all out in order from least to greatest. So 2 times 2 times 3 times 3. But again, we only use the prime factors. Whoops. I messed that up. Least to greatest, Mr. Ayers. Whoops. 2 times 2 times 3 times 3. Okay, make sure I got them all. 2 times 2 times 3 times 3. Again, only the ones in the circles, though. Alright, we can also do exponent form. Exponent form, which is where we look for repeated factors. Well, I've got 2, and I see that twice. So that's like 2 squared. Times, and there's 2 3s. So that's like, dot. That's like times 3 squared. Okay, so exponent form is 2 squared, because there's 2 of them, times 3 squared, 2 of them. 2 squared is 4, 3 squared is 9, 4 times 4 times 9 is 36. That's the number we started with, right? So that should make sense. Okay, well, for B, we can also do, okay, break down 45. And if we like factor trees, let's do that. Well, let's see, I know 5 times 9 is 45. 5 is prime, so I'm going to circle it. 9 is not, so I'm going to break it down into 3 times 3. Both of those are prime. Once I have all prime numbers that I can't break down anymore, I am done. So again, expanded form would be all the circle numbers. 3 times 3 times 5. 3 times 3 times 5. Exponent form would be 3 squared times 5. Okay? Now, those of you who don't like factor trees, okay, I like factor trees, but some of you may have learned downward division before. Okay, I want to cover that quick. Downward division I love. Okay, what you do with downward division is pick the lowest prime number that will go into this. So 2 is always the lowest prime number. And we ask ourselves, does 2 go into this? The answer is yes. 36 divided by 2 is 18. Does 2 go into that? Yes, it does. So I put another 2 out here. 18 divided by 2 is 9. Okay, does 2 go into 9? The answer is no. And this is not prime, so we got to figure out another prime number that goes into it. The next lowest prime number besides 2 is 3. Well, I know that 3 goes into 9. And when this number is prime, we are done. And these numbers right here, this little boot, okay, that's where all these numbers came from. Look at that. 2 times 2 times 3 times 3. Heck, they're already even in order for us with downward division. Okay, we could do the same thing with 45. Well, the lowest prime number that goes into 45 is 3. And 45 divided by 3 is 15. Lowest prime number that goes into 15 is 3. 15 divided by 3 is 5. And 5 is prime. There we go. There's our 3 times 3 times 5, just like we got here. Okay. Oh, whoops, don't forget. Got to circle and box our answers. Okay. For now, I'm not going to make you write out exponent form. I just wanted you to see it. They will make you write it later. Okay. If you want to write just expanded form for now, that's okay for prime factorization. If you want to do both, get better. Okay. Challenge yourself a little bit. See how that ties in together. That'd be fantastic. But again, I'm not going to make you. For now, you just need to have the expanded form. And that is the entire lesson. So I will take any questions. Yes, even the silly ones if you have them. Alright, but that should do it. So happy homeworking.